Perseverance Rover is on its way to Mars. In February, it will land in a fabulous area called Jezero Crater. It's right there on that edge between the land and the ancient ocean. What do we expect to find?
There could have been a habitable environment in that watershed area that picked up some potential biosignatures and deposited into the delta and got preserved.
Hi, I'm Jim Green, Chief Scientist at NASA, and this is Gravity Assist. On this season of Gravity Assist, we're looking for life beyond Earth.
I'm here with Dr. Kennda Lynch, and she is an astrobiologist and a geomicrobiologist studying life in extremes. She works at the Lunar and Planetary Institute in Houston, Texas. Welcome, Kennda, to Gravity Assist.
Thank you. It's so great to be here.
Well, you know, your current research really focuses on the studying of paleo lake basins here on Earth. And so that makes you a perfect expert to be involved in the Perseverance Rover, since it's going to Jezero Crater and land on an ancient lake basin, doesn't it?
I would say it makes me one of several really good experts that are really excited at the fact that we're going to Jezero.
Well, let's first discuss what we know about the Earth's paleo lake basins.
Absolutely. So what we know about Earth lake basins is a lot of our paleo lake basins, these were ancient lakes that were, in a lot of cases, very, very big, very deep lakes. Like, for example, Lake Bonneville, where my field site is, was an ancient lake of the Pleistocene era. And at one point, it was 1,000 foot in depth. It was very big, very deep, actually freshwater lake. But over time, because it was a closed basin lake and we had climate change, the lake started to dry out. It didn't have any outflows, so everything just evaporated. There's many of these across the world that we study. There, you know, the Great Salt Lake here in Utah. We also have Death Valley also has paleo lakes in it. The Salar de Uyuni in Bolivia also has one. We have paleo lakes in China in the Cadem Basin. So all these big lakes dried into these amazing playa environments where we have all of these lake sediments. We sometimes have occasional very, very shallow lakes that can develop in these environments. But we have amazing microbial diversity that can be found in these lake basin sediments after the lake went away. And that's what I like to study.
Well, what exactly are you looking for when you get these sediments?
We're looking at a couple of different things. Initially we wanted to just try to understand what these ecosystems look like. There really hasn't been a lot of research, believe it or not, in these kind of systems because people didn't really understand that they could be very, very rich in life. So the first thing we do is we do a lot of heavy biology. So a lot of looking for DNA and trying to understand what we call the phylogeny, who's there, how diverse they are, what does the ecosystem, what do the microbial communities look like? So that's, a lot of the first work that I did was understanding who's there and what they look like. Then the next thing we look for is how are they interacting with the environment? How are they interacting with the geochemistry? How are they living there? What are they eating? What are they breathing? How are they getting their energy? How are they interacting? All of these kinds of things. So we look for that and we try to understand that.
Kennda, can you tell me about a particularly memorable experience you had out in the field?
Oh, wow. There's so many. I'm going to give you two quick little ones. When we were at the center of the basin, where there's actually an actual well that my colleagues had put in permanently, we found a little mouse hanging out in the well, just kind of hanging out in the shade of the well. And, he had somehow gotten onto the playa, but he was hanging out there during the heat of the day. Well, the next day, when we came back to one of my boreholes that was about a mile away, that mouse was in my borehole using the borehole as shade. So he had overnight, had gone that whole mile and a half and kind of was using our borehole as a refuge for the day heat. It was very cute. And we got pictures of it. And then the second memorable experience was when we got our UTV stuck in some of the playa mud. That was a challenge.
The first mission to find perchlorates on Mars was Phoenix, but even Curiosity has confirmed that there are perchlorates, but not everywhere. What are perchlorates, and tell us a little bit about how are they important?
So perchlorates are what we call chlorine oxyanions. It's a chlorine atom surrounded by 4 oxygen atoms, and it's a really, really, really big oxidizer, very similar to oxygen. So it gives the same kind of energy release that oxygen does. And in fact, here on Earth, we use perchlorates as part of solid rocket fuel because when you light it up, it really gives a lot of energy that helps our rockets take off. People experience perchlorates every day in things like firecrackers, but we also know that perchlorate occurs naturally on Earth and, of course, on Mars. And on Mars, we see more perchlorate on Mars than we see anywhere on Earth. And so it's this incredible potential energy resource that life could use to generate energy and sustain an ecosystem. The other reason, which is not as exciting, but perchlorates on Earth, they can be toxic to humans. So we want to understand perchlorates so that we can make sure that it doesn't affect our astronauts when we send them to Mars, so that we can mitigate the perchlorates and make sure that they don't make our astronauts sick when we send our first human mission to Mars.
Okay, we are at our first sampling point.
This field site that you went to, the Pilot field site, where is it at, and why did you choose that?
So Pilot Valley Basin is a part of the Great Salt Lake Desert, which basically encompasses pretty much most of northwestern Utah. So basically, once you get past Salt Lake City, the rest of it is the Great Salt Lake Desert, and Pilot Valley is a sub-basin of that desert that actually, because of how it's nestled in between two mountain ranges, is kind of off on its own. It's all Jeep roads to get there. It's not that easy to get to. So there hasn't been a lot of anthropogenic input onto Pilot Valley, whereas other basins in the Great Salt Lake Desert, they do a lot of salt mining, a lot of economic geology. Pilot Valley's kind of been off on its own and pretty much left pristine. And how I found this environment actually very much relates to the Phoenix mission and our discovery of perchlorate. I was working with Dr. Sam Cunaves, who is a co-I on Phoenix at the time and is one of my long-term mentors and definitely a wonderful, wonderful scientist. And I was working with him on his sensors, his wet chemistry sensors. And during the Phoenix mission, I was in grad school, and he called me, and I think he actually might have called me from JPL and said, "Kennda, do you know anything about perchlorate?" And started me down this road about looking at perchlorate and microbes that can use perchlorate. And that the following summer, I was driving to Ames Research Center to start my Harriet Jenkins predoctoral fellowship summer portion. And I was driving through Utah and looking at the Great Salt Lake Desert. And I had done all this research about perchlorate and where it lives in the Atacama. And I'm looking at the Great Salt Lake Desert and I'm like, I wonder if there's perchlorate here. That would be kind of a neat environment to study. And so I wrote a little mini proposal to get this summer internship money the next summer from my school. And I went out and did a field expedition, and literally it changed my whole direction of my dissertation. And just, it just kind of keeps getting more and more interesting and more fun every time we go out there.
Well, there are other places in the solar system, that we were thinking of looking for life, like Europa. Are you doing any research on Earth that relates to Europa?
Definitely some of the work that we're doing in my basin, we're looking at perchlorate reducing bacteria in the hypersaline systems of my basin. One of my recent research papers that just came out last summer, where we basically documented our first discovery of a perchlorate reducing microbes cohabitating in an area where there's actually also naturally occurring perchlorate, something that's never been documented before. So now we have a relevant Earth analog ecosystem to learn about how perchlorate reducing microbes can live in kind of what on Earth is an extreme environment, but would be more of a normal environment on Mars or Europa, living in a brine or salty environment in Mars and Europa.
I remember that once you did a talk called All Life Poops. Does that mean that even bacteria has waste? And could we find traces of that in any of the samples that we bring back, whether it's from Mars or flying through the plume of Europa?
Yep, indeed. All life takes in energy and creates waste products, or for lack of a better word, poops. And it is indeed often these waste products that turn into biosignatures or possible biosignatures of life. For example, we're breathing poop right now. We are breathing tree poop. So oxygen is tree poop. So oxygen, molecular oxygen, is a potential biosignature that we look for in extrasolar planets. So absolutely, poop can be a biosignature.
Wow. You're absolutely right. I just never thought of it that way. But
I know people, it's so funny when I show kids, some of them go and try to hold their breath. They're like, I don't want to breathe poop. And I'm like, don't have a choice.
That. You need
that poop.
Okay. That's what makes different types of life coexist together. And in fact, we need that oxygen production from our plants.
Yep,
just
absolutely.
as they need the CO2 production that we create.
Yep.
So that's what creates a biosphere, is that important relationship between the different species of life.
Exactly.
So, Kennda, what about Perseverance is getting you really excited? When that lands in Jezero Crater, what do you want it to do?
I am so excited about what we call the bottom set deposits. These are these really, really fine deposits, really fine grains. They're usually mostly made up of clays and carbonates on Earth. They're really small particles that deposit in the lake basin and at the front of the delta that can make these great sediments where we can preserve organics and biosignatures. And I am so excited for Perseverance to go and start taking a look at those particular deposits in the crater. We're going to have some of the best chances of finding preserved organics in those deposits, because that's an environment on Earth where those kind of lake bed deposits or delta deposits, we know we get a lot of concentrated carbon that gets preserved and stabilized very well in those kind of deposits. So I'm really excited about the bottom sets.
So it's right there on that edge between the land and the ancient ocean. And this river was dumping into that when this impact occurred and created this huge crater we now call Jezero. Would you think we might be able to find some biomolecules if you've got complex carbon material that we're also finding? Is there a hope that we could do that?
I really do think so, because what's really amazing about these bottom set deposits is is that because of the lake environment and the fact that we have this delta, it could have come from 3 potentially different habitable environments within the Jezero Crater area. It could have come from up in the watershed, and the watershed is that area where all the water kind of flowed together into one big river or stream and deposited the water and the sediments that created the delta. There could have been a habitable environment in that watershed area that picked up some potential biosignatures and deposited into the delta and got preserved. It could have come from the lake itself, or it could have been preserved from a transitional habitable zone like I study, this subsurface environment where there's groundwater moving through these sediments after the lake's gone. And there could have been a subsurface ecosystem that could have lived there for a time before water retreated even deeper into Mars. And there could have been life that could have left some potential biosignatures there. So we have 3 different potential habitable environments that could have left biosignatures in these deposits. So I'm so excited to see what we can find out when we get samples from there.
You bring up something I hadn't really thought about, but indeed, with that lake over time being eroded away, and then the atmosphere becomes very thin, that's going to draw groundwater out.
Yeah, and especially since we know now that groundwater was a significant part of the hydrology on Mars, that's going to be a really important environment for us to start to kind of try to understand. So again, I'm so excited to see what we're going to be able to find out.
Well, you've also been involved in education and diversity efforts in what we call science, technology, engineering, and mathematics, or STEM. As an acronym. Can you tell us a little bit about what your efforts are and what you've been doing in this area?
I'm a lifetime member of the Girl Scouts. I was my mom's first Girl Scout, and my mom was worked on the professional staff. So I grew up in Girl Scouting and giving back and reaching out and educating. And so, I've just been doing it my whole life, all through college and undergrad. I've mentored so many students while working as a full-time engineer. I've done a lot of school presentations. And right now, and in grad school, I've mentored students and taught classes. Right now, I've got three students I'm mentoring, two directly at the LPI, one indirectly with a colleague who's asked me to mentor one of their students of color, and I'm very excited to be able to do that. I also do a lot of STEM outreach with our Education and Public Engagement Department here at the Lunar and Planetary Institute. I'm a Ford Fellow, so I interact with that community quite a lot and try to help help with efforts to increase diversity, equity, and inclusion across the space sciences and just STEM in general.
Well, I personally want to thank you for all that activity. I enjoy talking to the public and talking about the fabulous science that we do. You just can't stop me, and I'm just delighted that you're doing the same. Well, Kenda, I always like to ask my guests to tell me what was that person, place, or thing that happened that got them so excited that enabled them to become the scientists they are today. And I call that a gravity assist. So, Kenda, what was your gravity assist?
Well, there were so many people along the way. I can't recount them all, but what I will tell you is that my biggest gravity assist, the one that just makes me even kind of well up right now, is that my first summer internship at Kennedy Space Center, I was a space life science training program participant. I won't give you a year, but it was way back when the shuttle was flying. And it was my first, entry into the space world that I'd always wanted to be a part of. And I got accepted into that program. And the biggest gravity assist for me was seeing my first shuttle launch. They let us go out and watch the shuttle launch at Kennedy, and I got to see one of the shuttle launches, and that first shuttle launch, and watching that spacecraft go into the air and hearing the noise and watching the alligators jump out of the water because it was so noisy for them was just so inspiring. And just, I couldn't believe that at 20 years old I was there and I could be here and that I was a part of the space industry finally. And so that was definitely one of my biggest gravity assists that just kind of kept me going.
Well, that was wonderful. Well, thanks so much for joining me today. I've really enjoyed our discussion.
Me too. Thank you so much for having me.
Well, join me next time as we continue our journey to look for life beyond Earth. I'm Jim Green, and this is your Gravity Assist.